In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky that appeared completely empty, a black void roughly the size of a grain of sand held at arm's length. Some researchers thought it was a waste of valuable telescope time, because why would anyone stare at nothing for 10 days straight? What came back from that experiment changed everything we thought we knew about the cosmos. 10,000 galaxies emerged from the darkness, each one containing hundreds of billions of stars, and that was just one tiny speck of sky. The empty space you see when you look up at night turns out to be the most crowded place in the universe, and that fact alone should restructure how you think about reality. What you perceive when you gaze at the night sky has almost nothing to do with what actually exists out there. This isn't philosophy or metaphor, because physically, measurably, demonstrably, the cosmos plays tricks on human perception in ways most people never consider. Every single time you look up, you're not witnessing the universe as it currently exists. You're looking at the past, which makes you a time traveler whether you realize it or not. That star you're pointing at might not even exist anymore, because the light hitting your retina right now left that star decades ago, centuries ago, sometimes millions of years in the past. What you're seeing is cosmic history projected onto your eye. Here's the thing most people never stop to consider about the nature of space itself. That emptiness between points of light, that void you assume is nothing, turns out to be the most powerful and mysterious substance in the entire cosmos. We had no idea this was true until the last 100 years of physics ripped away everything we thought we understood. When you picture space, you probably imagine it as a stage or a container, the place where stuff happens, while space itself just sits around holding everything like some cosmic storage unit. Isaac Newton thought exactly this way, treating space as absolute and time as absolute, an unchanging backdrop against which the drama of the universe unfolded. That view seemed obvious and self-evident for centuries, and it turned out to be spectacularly wrong. Albert Einstein demonstrated that space and time weave together into a single fabric called space-time, and this fabric bends, curves, and warps whenever mass or energy shows up. What we experience as gravity isn't a force pulling objects together at all. The mass of the Earth bends space-time, and you follow that curve, which means you're falling along the natural geometry of warped space right now, constantly, with the floor just getting in your way. Something that should genuinely haunt you is the fact that your head is older than your feet at this very moment. And this is measurable. Time dilation from Earth's gravity means your head, positioned slightly further from the planet's center of mass, experiences time faster than your feet do. Over your lifetime, your head ages roughly 90 billionths of a second more than your feet, which isn't much, but also isn't zero. That tiny difference proves Einstein was right about the fundamental nature of time itself. GPS satellites have to account for this effect to function properly, and the technology in your pocket that tells you where to turn left depends entirely on Einstein being correct about space-time warping. Ignoring relativity would cause your GPS to drift by about 6 miles every single day, which shows how quickly the abstract becomes concrete. Back in the 1920s, Edwin Hubble was working at Mount Wilson Observatory in California when he made one of the most profound discoveries in human history. He examined distant galaxies and noticed something strange about their light, which was shifted toward the red end of the spectrum in every single case, in every direction he looked. The farther away a galaxy was, the more its light had shifted. When a source of light moves away from you, its wavelengths stretch out and get longer and redder. The same reason an ambulance siren drops in pitch as it speeds away from you. Hubble was seeing the Doppler effect written in light from distant galaxies. And what that meant was startling. Everything in the universe is moving away from us. Your intuition will betray you here, because the galaxies aren't flying apart through space like shrapnel from an explosion. Space itself is getting bigger, with every point in the cosmos moving away from every other point simultaneously. No center exists for this expansion, which means every location in the universe sees itself as the center, with everything else rushing away. You're at the center of the universe, and so am I, and so is a hypothetical observer in the Andromeda galaxy. That's not a contradiction, but rather the geometry of expanding space-time working exactly as the math predicts. The universe has no edge you can travel to and no boundary where space ends, because asking what lies beyond the universe is like asking what's north of the North Pole, a question that contains a conceptual error. What Hubble observed had actually been predicted a few years earlier by a Belgian priest and physicist named Georges Lemaitre, who looked at Einstein's equations and realized they implied the universe must be expanding. Running the clock backward meant everything converges to a single point, which Lemaitre called the primeval atom, the cosmic egg from which everything hatched. We call it the Big Bang today. Most people hear Big Bang and picture an explosion, some primordial bomb detonating in the middle of empty space and flinging matter outward. That image is completely wrong. The Big Bang was not an explosion in space, but an explosion of space, with space itself coming into existence alongside time itself. No, before the Big Bang exists in any meaningful physical sense, because time was part of what emerged in that first moment. The Big Bang happened everywhere at once, because in that initial instant, everywhere was the same place. The very fabric of reality, the arena in which everything you've ever known or experienced takes place, had a beginning, and we can still see its afterglow. The cosmic microwave background radiation represents the oldest light in the universe, a thermal echo of the Big Bang itself that was released about 380,000 years after the initial expansion. That's when the universe cooled enough for atoms to form and light to travel freely for the first time. The Planck satellite mapped this radiation with extraordinary precision. And what we see is a snapshot of the infant cosmos with tiny temperature fluctuations that would eventually become the galaxies, stars, and planets we observe today. You are looking at your own origin frozen in ancient light. And this is where it gets stranger still. Scientists measured the rate of cosmic expansion in the late 1990s. And what they discovered defied everything we thought we understood about gravity. Two teams of astronomers were studying distant supernovae to measure how much the expansion was slowing down. One team led by Saul Perlmutter and the other by Adam Rees and Brian Schmidt. Gravity should be pulling everything back together like a ball thrown upward, eventually falling back to Earth. But they found the exact opposite. The expansion is accelerating, which means the universe is not just getting bigger, but getting bigger faster, with galaxies rushing away from each other at ever-increasing speeds. The 2011 Nobel Prize in Physics went to those three scientists for this discovery, and we still don't fully understand what's causing it. We call this mysterious influence dark energy, a placeholder name that amounts to a confession of ignorance, dressed up as a scientific term. Roughly 68% of the total energy content of the universe consists of dark energy, and we don't know what it is. We've never detected it directly and only know it exists, because without it, the math falls apart. Something is pushing, something is stretching space itself, and after decades of brilliant minds attacking this problem, the answer remains elusive. Consider the economics of the universe for a moment, because 68% of everything that exists is an asset we can't see, can't touch, and can't interact with directly. The situation gets worse from there, because another phenomenon called dark matter also fills the cosmos. Dark matter operates differently from dark energy, holding galaxies together rather than pushing them apart. During the 1970s, astronomer Vera Rubin spent years meticulously measuring how galaxies rotate. And what she found was impossible according to conventional physics. Galaxies were spinning too fast for the visible matter they contained. Based on the stars, gas, and dust we can actually see, There isn't enough gravitational pull to keep these galaxies from flying apart, which means they should rip themselves to shreds. They don't, and the reason is that something invisible provides the extra gravity. That something doesn't emit light, doesn't absorb light, and doesn't interact with electromagnetic radiation in any way we can detect. Dark matter makes up about 27% of the universe. Add dark energy 68% to dark matter's 27%, and you get 95% of everything that exists, made of stuff we cannot see, cannot touch, and cannot detect directly. The atoms that make up you and me and planets and stars and galaxies, everything you've ever seen or measured or experienced, accounts for less than 5% of what exists. We're trying to understand the entire cosmic economy while blind to 95% of the capital involved. And if this were a business, the auditors would have serious questions. That fact should instill profound humility, because we're like a fish that has figured out the properties of water and declared it understands everything about Earth, completely unaware of continents, atmosphere, and the entire world beyond its tank. Light travels at 186,000 miles per second, fast enough to circle Earth 7.5 times in a single second, and fast enough to reach the moon in about 1.3 seconds. At that speed, light from the sun takes 8 minutes to reach your eyes, which means you never see the sun as it currently exists, but only as it was 8 minutes ago. Space is vast in ways that break human comprehension. Incomprehensibly, aggressively, absurdly vast. Proxima Centauri, the nearest star to our sun, sits about 4 light years away, meaning light traveling at the fastest speed possible in this universe takes 4 years to make the journey. The Andromeda galaxy, our nearest large galactic neighbor, lies 2.5 million light years distant. Light reaching your eyes from Andromeda left when our ancestors were still figuring out stone tools, which means you're seeing that galaxy as it existed before modern humans walked the Earth. The James Webb Space Telescope now peers even deeper into cosmic history, seeing galaxies that formed just a few 100 million years after the Big Bang. What's shaking up cosmology right now is that some of those early galaxies appear far larger and more mature than our models predicted, which shows the universe was building complex structures faster than anyone thought possible. We're watching theories get revised in real time, and that's science working exactly as it should. The observable universe has a horizon, a wall we can never see past, not because nothing exists beyond it, but because light itself hasn't had enough time to make the journey. We are epistemologically imprisoned by the speed of light, with the cosmos showing us its hand while clearly holding more cards. What exists beyond our cosmic horizon is presumably more galaxies, perhaps infinitely more, perhaps a universe that extends forever while we only ever see this tiny bubble of observable reality defined by the age of the cosmos and the finite speed of light. Some knowledge may be permanently beyond our reach, not because technology limits us, but because physics itself draws the boundary. Black holes bend not just space, but human comprehension. And in 2019, the Event Horizon Telescope collaboration revealed the first image of M87 star, a supermassive black hole sitting 55 million light years away in the Virgo galaxy cluster. 3 years later, in 2022, they showed us Sagittarius A star, the 4 million solar mass monster lurking at the center of our own Milky Way. These regions contain mass, compressed to such density that space-time curves infinitely, allowing nothing to escape, not matter, not light, not information. At the boundary of a black hole, called the event horizon, space and time effectively switch roles. Falling past that boundary is like falling into the future. And you cannot go back because returning would require traveling backward in time. Inside a black hole, the singularity at the center isn't positioned in front of you in space, but ahead of you in time, making it your future with no possibility of escape. LIGO, the Laser Interferometer Gravitational Wave Observatory, detected ripples in space-time itself. In 2015, created by two black holes spiraling into each other 1.3 billion years ago. Einstein predicted these gravitational waves a century earlier, but instruments sensitive enough to detect them didn't exist until recently. Now we're listening to the universe vibrate because the cosmos has a soundtrack, and we've just learned how to hear it. Looking at the night sky with your naked eye reveals maybe a few thousand stars on a clear, dark night, which seems like a lot until you realize those are just the nearest and brightest ones. Our Milky Way contains somewhere between 200 and 400 billion stars. And if you started counting one star per second, you need over 6,000 years to count just the stars in our galaxy alone. The Milky Way represents just one galaxy among hundreds of billions, perhaps 2 trillion galaxies scattered across the observable universe. These numbers break human cognition because we evolved to track a few dozen tribe members and count berries in our hand, not to contemplate 10 sextillion stars. The beautiful part is that the very atoms making up those incomprehensible stars are the same atoms making up you. You're not just made of star stuff, but made of dead star stuff, stellar corpses assembled over billions of years. Every carbon atom in your body was forged in the heart of a star that lived and died before our solar system existed. The iron in your blood came from a supernova explosion, a star that ran out of fuel, collapsed under its own gravity, and detonated with enough energy to briefly outshine an entire galaxy. The calcium in your bones required a different type of stellar furnace than the oxygen you're breathing right now. You are assembled from the wreckage of nuclear catastrophes scattered across billions of years, because the universe builds through destruction. You are the phoenix, and you don't even realize it. This is not poetry, but literal chemistry, and no boundary separates you from the cosmos. The universe is in you, and you are in the universe, arranged temporarily into a pattern complex enough to ask where it came from. Some people hear all this and feel small, insignificant, a pale blue dot drifting through an ocean of darkness. That reaction makes sense, but misses something important. Of all the possible arrangements of matter, of all the ways atoms could have combined and recombined across 14 billion years, some of them ended up as configurations that can contemplate their own origins. The universe doesn't do that very often, because stars don't wonder where they came from, and galaxies don't ask questions. You do, and that's not insignificant, but extraordinarily rare. Every time you look up at the night sky, you're looking at a 14 billion year story written in ancient light. You're seeing the nuclear fires of distant suns, the echoes of primordial expansion, the ghosts of galaxies so far away that the universe has transformed profoundly since their light began traveling towards you. You're seeing the past suspended in the present, hinting at a future we can barely imagine. The remarkable thing is that you can understand this, because the same atoms, forged in dying stars, arrange themselves into neurons capable of reconstructing the history of the cosmos. That's what space really is. Not emptiness, not void, not a stage waiting for actors. Space is a dynamic, expanding, warping, mysterious fabric connecting everything to everything across all of time. It carries gravitational waves like ripples on a pond, stretches faster than light at cosmic scales, bends around mass like a trampoline under a bowling ball, emerged from nothing and may expand forever into cold darkness. You are not separate from it and never were. You're made of it, swimming in it, shaped by it, briefly aware of it. And in that awareness, you participate in something extraordinary. The universe, after 14 billion years of evolution, finally developing the capacity to know itself.